Namaste children. A warm welcome to all of you for this first session. Today we will discuss one of the most important chapter of our 10th standard mathematics, that is polynomials. Now let us start polynomials. First we will take degree of polynomials. If p of x is a polynomial in x, the highest power of x in p of x is called degree of the polynomial p of x. Once again, p of x is a polynomial in x. The highest power of x in p of x is called the degree of the polynomial in p of x. For example, 4x plus 2 is a polynomial in the variable x of degree 1. Look at this figure. Look at this. 4x plus 2. Here is x. The degree is 1. Is a polynomial in the variable x of degree 1. Now we can take the second example. 2y square minus 3y plus 4 is a polynomial in the variable we can take y variable y of degree 2. Here is 2y square minus 3y plus 4. Here is the highest degree. The degree is 2. Now we can take third example. 5x to the power 3 minus 4x square plus x minus root 2 is a polynomial in the variable we can take variable x of degree. Dear students, the highest degrees, this is degree 1, degree 2, degree 3. The highest degree is 3, then the variable of x of degree 3. Now we can take the fourth example. 7x to the power 6 minus 3 by 2 x to the power 4 plus 4x square plus x minus 8 is a polynomial in the variable x of degree. Once again I will explain. The degree is 2, 1, 2, 4. The highest degree is x to the power 6. That is, the degree is 6. Once again, you observe this 1 by x minus 1, comma, root x plus 2, comma, 1 by x square plus 2x plus 3, etc. These are the polynomials? No, are not polynomials. 1 by x minus 1, root x plus 2, 1 by x square minus plus 2x plus 3, etc. are not polynomials. You can observe some points. Next one, linear polynomials. A polynomial of degree 1 is called a linear polynomials. Linear polynomials degree is 1. You can observe linear polynomial degree is 1. Some examples are 2x minus 3, comma, root 3x plus 5, y plus root 2, comma, x minus 2 by 11, 3z plus 4, and last one 2 by 3 u plus 1, etc. All are linear polynomials. Linear polynomials. Polynomials such as 2x plus 5 minus x square, comma, x cube plus 1 are not linear polynomials. Why? Why 2x plus 5 minus x square and x cube plus 1 are not linear polynomial? Because their degrees are 2 and 3, but in case of linear polynomials the degree is 1. That's all. These are not linear polynomials. Next one, quadratic polynomials. A polynomial of degree 2 is called quadratic polynomials. Quadratic polynomials. Quadratic polynomials. Examples are, the examples of quadratic polynomials are 2x square plus 3x minus 2 by 5, comma, y square minus 2, comma, 2 minus x square plus root 3x, and last example is u by 3 minus 2u square plus 5. These are all examples of quadratic polynomials. Are some examples of quadratic polynomials. Quadratic polynomials. Examples of quadratic polynomials. So, quadratic polynomials in x is of the form ax square plus bx plus c. Once again, quadratic polynomials in x is of the form ax square plus bx plus c, where a, b, c are real numbers where n is not equal to 0. This is the quadratic formation of the polynomials. So, second one, a polynomial of degree. Once again, a polynomials of degree 3 is called a cubic polynomials. For examples, 2 minus x cube, comma, x cube, comma, root 2 x cube, comma, 3 minus x square plus x cube. The last example is 3x cube minus 2x square plus x minus 1. These are the examples of the cubic polynomials because their degrees is 3. Their degree is 3. In first example, the degree is 3. In second example, the degree is 3. In third example, degree is also 3. But in fourth example, degree 2 and 3 are here. First we take highest degree 3, and fifth example 3x cube minus 2x square plus x minus 1. The degrees are 1, 2, 3. We take highest degree 3. So in fact, the most general form of a cubic polynomial is ax cube plus bx square plus cx is equal to d. In fact, the most generalized form of a cubic polynomial is ax cube plus bx square plus cx plus d is equal to 0, where a comma b comma c comma and d are what? Real numbers. Real numbers, and A is not equal to 0. A is not equal to 0. 7 u to the power 6 minus 3 by 2 u to the power 4 plus 4 u square plus u minus 8 is a polynomial of variable x, and the degree of this degree of this polynomial is what? The highest degree is, in this example, the highest degree is 6. Here is 1, 2, 4, 6. The highest degree is 6. 7 u to the power 6 minus 3 by 2 u to the power 4 plus 4 u square plus 4 minus 8 is a polynomial of variable x, and the degree of the polynomial, the highest degree is 6. Coming to the next point, if p of x is a polynomial in x, and if k is any real number, first you take p of x is a polynomial in x and f is taken as real numbers, then the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to k is denoted by p of k. Once again, p of x is a polynomial in x, in k is a real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to k and is denoted by p of k. Coming to the next point, what is the value of p of x is equal to x square minus 3x minus 4 when x is equal to minus 1 and x is equal to 4. x ನ ಬೆಲೆಗಳು, x ನ ಬೆಲೆ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? x ನ ಬೆಲೆ -1 ಮತ್ತೆ x ನ ಬೆಲೆಯನ್ನು 4 ಕೊಟ್ಟಾಗ ಈ ಪಾಲಿನಾಮಿಯಲ್ ಇರತಕ್ಕಂತ ಇದರ ಬೆಲೆ ಏನು? ಪಾಲಿನಾಮಿಯಲ್ ಅದು p of x is equal to x square minus 3x minus 4. First, p of x is equal to x square minus 3x minus 4. We take x is equal to minus 1. Here substituting x in this place, minus 1 is equal to x square means minus 1 whole square minus 3 into minus 1 minus 4. Minus into minus, 1 into 1 means 1. Minus into minus plus 3 ones are 3 minus 4 is equal to 4 plus 4 minus 4 is equal to 0. P of minus 1 is equal to 0. Here we take polynomial p of x is equal to x square minus 3x minus 4. We take the x value, x is equal to 4. Substituting the 4 in p of x, instead of 4 is equal to 4 square minus 3 into 4 minus 4. 4 4s are 16 plus into minus minus 3 4s are 12 minus 4. 16 minus 12 minus 4 is equal to minus 16. Minus minus 16 cancel 0. P of 4 is equal to 0. Now we take P of minus 1 is equal to 0 and P of 4 is equal to 0. Minus 1 and 4 are the zeros of the quadratic equations. Minus 1 and 4 are called the minus 1 and 4 are called the zeros of the quadratic equation. What equation? X square minus 3x minus 4. Minus 1 and 4 are called the zeros of the quadratic equation x square minus 3 minus 4. If k is a real number such that p of k is equal to 0, then k is called the zeros of the polynomials p of x. The second point, if k is the zero of the polynomial p of x is equal to ax plus b, then p of x is equal to, look at this, where x is equal to k. If k is the zero of the polynomial p of x is equal to ax plus b, then x is equal to k, then we can write p of x instead of p of k. P of k is equal to ax plus b is equal to 0. That is, ax is equal to minus b, sorry, ak plus b, ak is equal to minus b. Once again, I will write ak plus b, ak plus b is equal to 0, ak is equal to minus b, therefore k is equal to minus b by a. K is equal to minus b by k. So, the zero of the linear polynomial a of x plus b is equal to, so the zero of the linear polynomial ax plus b is equal to minus b by a is equal to minus b constant term. And coefficient of x. Once again, write coefficient of x. Once again, the zeros of the linear polynomial ax plus b is equal to minus b by a is equal to minus constant term divided by coefficient of x. So, second heading, geometrical meaning of the zeros of a polynomial. First one is, you can already learn linear polynomial. First you can take one example, y is equal to 2x plus 3. Here is the x-axis, this is x coordinates and y coordinates. First we take y is equal to 2x plus 3. Substitute the value of x is equal to minus 2. Y is equal to 2 into minus 2 plus 3. Y is equal to plus into minus, minus 2 2s are 4 plus 3. Substitute 3 in minus 4 is equal to minus 1. We will take 2 2s are 4 plus into minus minus plus 3. Minus 4 plus 3 is equal to minus 1. We take minus 1 in y axis or y coordinates. Second one, y is equal to 2x plus 3. Y is equal to, we substitute 2. Y is equal to 2 into 2 plus 3. Y is equal to 2 2s are 4 plus 3. Y is equal to 4 plus 3, 7. Here the value of y is 7. The first value of y is minus 1. We can take the 7 in this column. So y is equal to 2x plus 3. The x coordinates is minus 2 in case of y is minus 1. Where we take the x value of 2 and we get obtained y is equal to 7. Now, dear students, in the previous class, we already learned coordinate geometry. In coordinate geometry, some basic points. This is x-axis, this is y-axis, 0. These are the positive values, these are the negative values. We can take positive values and take negative values. 1, 2, 3, minus 1, minus 2, minus 3, 1, plus 1, 2, 3, minus 1, minus 2, minus 3. This is x-axis, x O x dash, y O y dash. The O is called horizon, 0, 0. So, we take them as first quadrant plus first quadrant. This is second quadrant. This is third quadrant. This is fourth quadrant. Minus plus. Second quadrant minus plus. We take the x-axis minus value. We take the y-axis plus value. And this is minus minus third quadrant. We take x-axis minus values and y-axis is also minus values. We take on the fourth quadrant plus minus. We take the positive values, x-axis is positive values and y-axis is negative values. These are some basic points of coordinate geometry. First, we consider linear polynomial. Here is the graph. The equation is y is equal to 2x plus 3. The x coordinates are minus 2 and 2. The equation y is equal to x plus 3. First we take x is equal to minus 2, we obtain minus 1, and x is equal to 2, we obtain 7. The graph y is equal to 2x plus 3 is a straight line passing through the points minus 2, comma minus 1 and 2, comma 7. Here, dear children, look at the figure. You can observe carefully the graph y is equal to 2x plus 3 is a straight line passing through the points minus 2, comma minus 1 and 2, comma 7. The graph of y is equal to 2x plus 3 intersects the x-axis, midway between x is equal to minus 1 and x is equal to 2. Here is the x-axis. Y is equal to x plus 3 intersects the x-axis in the midway between minus 1, minus 2. That is the point minus 3 by 2, comma 0. You also know that the 0 of the 2x plus 3 is minus 3 by 2. Thus, the 0 of the polynomial 2x plus 3 is the x coordinates of the point, whereas the graph of 2x plus 3 intersects the x-axis. Here is the graph x of x coordinates of the point, whereas the graph y is equal to 2x plus 3 intersects the x-axis. Therefore, the linear polynomial ax plus b, comma, where a is not equal to 0 has exactly 1, 0, namely the x coordinates of the point where the graph of y is equal to ax plus b intersects the x-axis.